video, we're going to practice quotient rule with trig functions. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. The idea with this video is that now that we have quotient rule, we can use that to find the derivatives of the other trig functions, mainly anything that's not sine or cosine. I think a lot of people spend a lot of mental energy trying to memorize all the derivatives of tangent and cotangent and so on, and you really don't need it. Because if you know quotient rule, and if you know the derivatives of sine and cosine, then even if you blank, it's okay. You can still remember or just figure out what the derivatives are. So all we're going to be doing really is just looking at these types of functions and saying, how can we use quotient rule to find the derivatives using what we already know? So all the problems are going to start with not taking a derivative, but rather rewriting these functions as quotients. So we know tangent is sine of x over cosine of x. And like I said, instead of taking the derivative of this, we'll take the derivative of this, since we know quotient rule and since we know the derivatives of sine and cosine individually. So the derivative, you're going to use quotient rule. So dy dx equals, so low d high, so cosine of x times the derivative of the top is cosine of x minus high sine of x d low, and that's going to be negative sine of x, an extra parentheses there, all over low low. So that's going to be cosine of x squared. So here we have cosine times cosine, and here we have minus sine times negative sine. So this simplifies to cosine squared of x plus sine squared of x all over cosine of x. And actually I can write that as cosine squared. Now, at this point, we can apply the basic Pythagorean trig identity, in that cosine squared plus sine squared, that's just going to equal 1 on the top. And then we're left with cosine squared of x on the bottom. Now 1 over cosine is secant, so 1 over cosine squared is secant squared of x. And so there is our derivative of tangent. Again, we wrote it as a quotient, and then we applied the quotient rule. And so that's what we're going to continue to do with these other examples. So let's go on to the next one. So at the next one, we have s equals cotangent of t. So when we write this, this is going to be cosine of t on top and sine of t on the bottom. So now that we've written it as a quotient, let's write our derivative. Now here we don't have x and y, here we have s and t, but that's okay. T is our independent, s is our dependent variable. So when we write the derivative, it's going to be ds dt. So quotient rule says low d high, so sine of t times negative sine, that's the derivative of the top, minus high d low, so that's cosine of t times cosine of t, all over the denominator sine of t squared. So now we combine our like terms here. Sine times negative sine, that's negative sine squared of t, minus cosine times cosine is cosine squared t, all over sine squared of t. Now here we have negative sine squared and negative cosine squared, whereas in the first one we had positive sine squared and cosine squared. That equaled 1 up there, so down here this is just the opposite. So this will equal negative 1 over sine squared t. And so this will equal negative cosecant squared of t. And what you'll notice is that tangent and cotangent are reciprocals, but their derivatives are kind of similar. They're both squared, except this one is secant and this one is negative cosecant, and they're both squared. And you'll see a kind of similar relationship going on with the other two. So let's look at those. So with number 3, we've got cosecant. So first we'll write this as a quotient. So this is 1 over sine of x. So now to apply our derivative, f prime of x, and applying quotient rule, it's low d high, so sine of x times, now the derivative of the numerator is just going to be 0, minus high, that's 1, times the derivative of the denominator, which is cosine of x, all over sine of x, and that quantity is squared. Since that first term is multiplied by 0, that's just going to go away. So we're left with negative cosine of x over sine squared of x. Now we could stop here, but we're not going to, because most resources, most textbooks, most internet sites don't show this as the derivative of cosecant. What they do is they break up the denominator, whereas in the numerator we just have one factor, negative cosine. In the denominator they have sine times sine. And what they do is they break this up into two distinct fractions. Negative cosine of x over sine of x times 1 over sine of x. And so we have negative cosine of x over sine of x, so that's cotangent of x, times 1 over sine of x is cosecant of x. And this is what you will see in most resources when you look up the derivative of cosecant. It'll be written like that. Is this up here wrong? No, but the consensus is this is the form that they're going to tend to use. So we'll follow along. So now for number 4, here we have secant. So we'll write this as 1 over cosine of t. So our derivative is going to be dy. That's our dependent variable. Our independent variable is dt. So dy dt. On the top, we're going to have low d high. So cosine of t times 0 minus high d low. So that's 1 times negative, put a parentheses, sine of t all over low, low, so that's cosine of t squared. Like with number 3, this is being multiplied by 0, so it's going to go away. Here we have a negative times a negative, so we're left with a positive. So sine of t over cosine squared of t. Now, similar to number 3, we're going to break this up into two separate fractions. So we're going to write this as sine of t over cosine of t times cosine of t. And then as separate fractions, that's going to be sine of t over cosine of t times 1 over cosine of t. And so that's going to equal, this right here is tangent of t, and 1 over cosine is secant of t. And so when you look up the derivative of secant, this is what you will find. Now, 2 more examples really quick. We've gone through the 4 trig functions that aren't sine and cosine, and so we now have their derivatives. And so here we've got this problem, 3x times cosecant x. Now what this is a product rule problem, because this is one function and cosecant of x is a separate function. And so since we know now the derivative of cosecant, we can treat this as a product rule. So as a product rule, we're going to first take the derivative of 3x, which is 3, times, and we're going to leave cosecant alone, plus, then we're going to leave 3x alone, times, and then the derivative of cosecant, which we found in number 3, that's negative cotangent of x times cosecant of x. And to simplify this, we can factor out like terms. Both of these have a 3 in common, and both of these have a cosecant in common. And so when we factor that, we're left with a 1 from the first term. Here we're left with an x and a negative cotangent. So negative x times cotangent of x. So if we simplify that, we'll get rid of the plus minus. So cosecant of x times 1 minus x cotangent of x. Now, one other way you could approach this problem if you want to is you can treat this as a quotient rule and say that this is equal to 3x over sine of x. And this isn't wrong. This is an alternative way of doing this because that's how we understand cosecant. Cosecant is 1 over sine. So if you find quotient rule easier, then I would suggest working this out and seeing can you get your way to this same answer. All right. Now for the last problem, here we've got this quotient already. Now actually quotient rule is probably more trouble than it's worth because what we can do is we can simplify this in light of the fact that we know the derivatives of secant, cosecant, tangent, and cotangent. How do we do that? Well, we have 2 terms on the top and just 1 factor on the bottom. So we can write this as 1 over cosine of theta minus sine of theta over cosine of theta, which simplifies to secant of theta minus tangent of theta. So now, since we know this, now we can go ahead and simply substitute in the derivatives that we know for secant of theta and tangent of theta. So for secant, that's going to be tangent, our variable here is theta, times secant of theta, minus the derivative of tangent is secant squared theta. And depending on how your teacher would want your answer to be simplified, here we can factor out a secant out of both of these. So we have secant of theta, and we're left here in the first term with tangent of theta minus secant of theta. And so here, hopefully this helps you, and hopefully you don't have to memorize all the rules for secant, cosecant, tangent, and cotangent. Remember that, well, with quotient rule, with sine, with cosine in hand, we can now just know those. And if you blank on them, well, you can just work it out again. So, if you like this video, please give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. If you want to support the channel, click the Patreon link to help keep this going. Thank you so much for watching. And remember, the only way to understand something is to do it.